TLS certificates secure your connections every day, encrypting traffic between your browser and the websites you visit. But how do you know the certificate your browser receives is actually legitimate? What if someone intercepted your connection and presented a fraudulent one? DNSimple now supports TLSA records, giving you a powerful way to verify TLS certificates directly through DNS. In this video, we'll cover what TLSA records are, how they work, and why they matter for securing your domains. Before diving into TLSA records, let's briefly cover TLS, or Transport Layer Security. TLS is the protocol that encrypts traffic between a client and a server, protecting your data from eavesdropping and tampering. When you see the padlock icon in your browser, TLS is at work. TLS relies on certificates issued by certificate authorities to verify that a server is who it claims to be. Your browser trusts a list of certificate authorities, and when a server presents a certificate signed by one of those authorities, your browser will accept the connection as secure. Here's the problem. The certificate authority system has a single point of failure. If a certificate authority is compromised or issues a certificate incorrectly, an attacker could present a valid-looking certificate for your domain. This has happened before, and it's a risk that TLSA records help mitigate. What is a TLSA record? A TLSA record is a DNS record that associates a TLS certificate, or its public key, directly with your domain name. TLSA stands for Transport Layer Security Authentication, and it was defined in RFC 6698. TLSA records are part of a larger framework called DANE, or DNS-based Authentication of Named Entities. DANE uses DNSSEC signed DNS records to provide an additional layer of certificate verification, independent from the traditional certificate authority system. Think of TLSA records as a notarized signature. Your signature is the TLS certificate, showing that you authored it, and the TLSA record is providing verification that the signature is genuine. A TLSA record has a specific structure with 4 key fields. Understanding these fields helps you configure TLSA records correctly for your use case. The certificate usage field specifies how the certificate data should be used for validation with 4 possible values. PKIX-TA acts as a constraint, requiring that the certificate chains to a specified certificate authority. PKIX-EE is a service certificate constraint that must match and pass PKIX validation. DANE-TA is a trust anchor assertion where the specified certificate becomes the trust anchor. And finally, DANE-EE is for domain-issued certificates, matching the certificate directly without requiring a certificate authority. The selector field indicates whether to match the full certificate or just the public key. The matching type field defines how the certificate data is represented. This could be as a hash or the full data. The certificate association data field is a hex string that contains the certificate data or the hash that is to be matched against. Here's an example of a TLSA record when it's queried with dig. The name indicates that this TLSA record applies to port 443 over TCP for example.com. The values 311 mean DANE-EE usage, public key selector, and SHA-256 matching type. How do TLSA and DANE work together? DANE ties TLSA records to DNSSEC, creating a chain of trust from the DNS root all the way to your certificate data. Let's go through the steps of how TLSA records work and get recognized by DNSSEC to verify your TLS certificate. First, you publish a TLSA record in your DNS zone containing your certificate's information. Then, DNSSEC signs that record, ensuring that the TLSA data cannot be tampered in transit. A client then connects to your server and receives your TLS certificate. When the client queries DNS for the TLSA record associated with your domain and port, it then verifies that the certificate it received matches the TLSA record data. If the certificate doesn't match the TLSA record, or if the DNSSEC signatures don't validate, the client knows something is wrong and can reject the connection. This removes the single point of failure inherent with the certificate authority system. Even if an attacker obtains a fraudulent certificate from a compromised certificate authority, they cannot forge the DNSSEC signed TLSA record in your zone. The client will detect the mismatch and then refuse the connection. Why use DNSimple for TLSA records? Managing TLSA records requires a DNS provider that supports both the record type and DNSSEC. DNSimple offers both, along with tools that make managing your DNS infrastructure straightforward. DNSimple provides one-click DNSSEC activation with automatic key management and signing, so you don't need to handle the complexity of key rotation yourself. Create and manage TLSA records through our web interface, REST API, or Terraform provider. DNSimple's Terraform provider lets you manage your DNS records, including TLSA records, as version-controlled code. When you renew certificates, you can update your TLSA records through your standard development pipeline, ensuring your DNS stays in sync with your infrastructure. You can even integrate TLSA record updates into your certificate renewal process. When your certificates renew, your Terraform configuration or API calls can update the TLSA records automatically, maintaining DANE validation without manual intervention. If you're ready to automate your TLSA records, try us free for 30 days. Check out other videos on our channel and read our comic linked in the description. For more information about DNSSEC and how it secures your DNS, watch this video next.